Hello my dear students, welcome to Deeksha Karnataka, and today's live session I will be discussing not one, not two, but three chapters. So I will be discussing moving charges and magnetism. I will be discussing magnetism and matter, electromagnetic induction, and EM waves. Now I just wanted to ask something from all of you. There's extremely sorry that the lecture of EMI and EM waves was supposed to go today at 9 AM, but due to some technical issue it was aired in the evening, but the live was already planned for all these 4 chapters, so I kept all the 4 chapters. This will be very important if you are preparing for your KCET. Obviously moving charges and magnetism, one of the most important chapters. 4-5 questions usually come from this chapter. Magnetism and matter is something which I like to tell you that many concepts from this chapter are deleted from where KCET questions used to come. So what I have done, I have taken a few older years of questions and I have not given any years to them because the years were not very authentic. Some sources are saying from different years for the same question. So magnetism and matter questions are not year wise marked except 2025 question. Even 2024 2 questions came from this chapter. Both are now out of syllabus. Okay, in 2023 also. So most concepts from this chapter that used to come in KCET are now deleted. So I have not given any year marked question for magnetism and matter. Electromagnetic induction is another important chapter. From here again you are expecting 3 questions. Electromagnetic wave, the easiest, simplest chapter. From there you can expect 1 question like always. Right, so we will start with moving charges and magnetism, then we will move to magnetism and matter, and last we will discuss EMI and EM waves. Okay, so let's start. Too thin, long, there is just a slight formatting error. Let me check it once if there is a formatting error in any of the other slides. So let me check. Where is my ticker? So let me fix if there is any other formatting error. Okay, no formatting error, only except the first question. Let me fix it quickly. Give me a second, guys. Okay, so it is fixed. Now let us start. 2 thin long parallel wires separated by a distance small r from each other in vacuum carry a current I ampere in opposite directions, then they will. So 2 thin parallel wires, 2 thin parallel wires carrying current in the opposite direction. Okay, so opposite direction current, they always repel each other, right? Same direction current, they attract each other. Opposite directional current, they repel each other. Okay, so they will repel, but what will be the force per unit length? Force per unit length will be, both of them are carrying current I, so force per unit length will be mu naught by 2 pi I square upon d. Okay, mu naught by 2 pi I square upon d, not I square upon d square. So here the distance, instead of d it is given r, so it will be I square by r. Okay, it will be I square by r, and it will be repulsion. Why repulsion? Because opposite current repel each other, same current attract each other. So what will be the answer for this question? So if you are watching, please try to answer in the chat by mentioning the question number. So question number 1, correct answer is option 1A. Repel each other with a force of unit length mu I square by 2 pi r. Okay, so this is square. Okay, this is not 2, this is square. Now let's move on to the next question. A solenoid is 1 meter long and 4 centimeter in diameter. Okay, solenoid is 1 meter long and 4 centimeter in diameter. It has 5 layers of windings of 1000 turns each and carries a current 7 ampere. The magnetic field at the center of the solenoid. So here we have a solenoid, and it has not 1, not 2, but it has 5 layers. 5 layers means, so this is one layer. On top of it, if you add one more, it will be second layer. Okay, and if you in top of it, if you add another one, it will be third layer. Like that, there are how many layers? 4, and then lastly 5. Each layer has total windings of 1000 turns. So total each 1, 2, 3, 4, 5, all of them has 1000 turns, right? The length is fixed. Length of this is 1 meter. So first of all, we have to find total number of turns. Total number of turns is number of turns, that is in this case 5, times each turn has 1000 turns. So total number of turns is 5000. Okay, some students may ignore this 5 layer. What is this 5 layer? I don't understand. So in that case, you have to understand that 5 layer means each layer has 1000 turns, and each 1000 turns with 5 layers basically gives you 5000 turns. So number of turns per unit length is given by number of turns divided by length. Here length is 1 meter, so it will be simply 5000. So 5000 is the total number of turns per unit length. Now what is magnetic field due to a solenoid? Magnetic field due to a solenoid is mu naught small n into I. Now what is mu naught? Mu naught is 4 pi into 10 to the power of minus 7. Number of turns is 5000, and the current that is being passed is 7. Current that is being passed is 7. Now to solve it quickly, what we will be using? We will use pi as 22 by 7. Okay, 10 to the power of minus 4 into 5 into 7. So these 3 zeros I have adjusted over here. 7 cancels. Now what is left? Only the multiplication. So 4 into 5 is 20. 20 into 22 is 440. So 440 into 10 to the power of minus 4 Tesla. Okay, so 444 into 10 to the power of minus 4 Tesla, or if you see in the option, 444 is not given directly, 10 to the power of minus 4 is not given, this value is given, which is obviously not correct. So we have to adjust the 10 to the power of value. So 4.4 into 10 to the power of minus 2 Tesla. So now if you see the options, only correct answer is option A. Now if you see, sir, I have solved 4.4 in the option, 4.396 is given. Okay, you are welcome. Use pi value 3.14 and try to solve it. It will take a longer time and it will take a longer effort to solve it. So what we have done, we have taken the value as per the given data, because 7 ampere was given. So we have smartly chosen 22 by 7, which is not exactly accurate value of pi, which is close value of pi. Okay, so that is why we have taken it and we have simplified the answer to be 4.4. Now let's move on to question number 3. Two similar galvanometers are converted. Sorry, not covered. Two similar galvanometers are converted into an ammeter and milliammeter. The shunt resistance of ammeter as compared to the shunt resistance of milliammeter will be. So shunt resistance of ammeter to shunt resistance of milliammeter. Let's see. Here we have an ammeter which measures the current in the range of amperes, and here is the shunt resistance of the ammeter, say SA. Okay, now here we have the milliammeter and here we have the shunt resistance of the milliammeter. Now what is a milliampere? Milliampere means the current that it is measuring is in milliampere. So this current is in milliampere, this current is in ampere, this current is in ampere. So what happens is that because they are same galvanometer, the maximum galvanometer current should be same for both the galvanometer. Maximum galvanometer current allowed to pass through the ammeter or milliammeter should be same. Only thing what we are doing, we are converting one into ammeter, one into milliammeter by changing the shunt resistances. That's it. Now if you see here, what is the current that is being passed through the shunt resistance? Current that is being passed through the shunt resistance is given by I in ampere minus Ig. What is the current that is passed through the shunt? In case of milliampere, it is IMA minus Ig. So obviously, suppose we are measuring 1 ampere, Ig is 0.1, then remaining 9.99 ampere will pass through the shunt resistance. In this case, you are measuring say 100 milliampere, the current is 10 milliampere, because 0.1 ampere means 10 milliampere, 0.1 means 100 milliampere. So suppose you are measuring 500 milliampere. The current that is being allowed through this is 100 milliampere. Remaining 400 milliampere will pass through shunt resistance. So because in case of ampere, more amount of current is being passing through the shunt resistance, the value of shunt resistance in case of a milliampere should be much smaller than shunt resistance of a milliampere. Okay, milliampere should have a higher shunt resistance. Normal ampere should have a very small shunt resistance if the galvanometers are same. Okay, because milliampere, in case of milliampere, the current that is passing through shunt is smaller because the difference is smaller. In case of ampere, the difference is bigger, so shunt resistance has to be very low value so that it can accommodate that extra current being passed through it. Okay, so the shunt resistance of ammeter should have should be less compared to that of a milliammeter, right? Now let's move on. Very interesting question, very interesting, came in 2025, but if you have no idea how to answer it, you may not be able to answer it. Now next question, identify the correct statement. A straight current carrying conductor has circular magnetic field lines around it. So correct statement, that means only one is correct. So if you have a current carrying wire, the magnetic field lines is circular around it. Okay, the direction of magnetic field due to a current element is given by Fleming's left hand rule. No, it is given by Biot-Savart's law. The magnetic field inside a solenoid is non-uniform, it is uniform. Current carrying conductor produces an electric field around it. Current carrying conductor does not produce electric field, it only produces magnetic field. So obviously option A is correct, right? Option A is correct. Straight current carrying wire produces magnetic field around it, right hand thumb rule. So in 2025, you can see 5 questions came from this chapter. 5, not 1, not 2, not 3, not 4. 5 questions came from this chapter alone. So that's why this is a very, very important chapter. Which of the following graphs represents the variation of magnetic field B with perpendicular distance small r from infinitely long straight current carrying conductor? Now this question, this type of question is very common in KCET, and as I told you, if you are in doubt, hi, good morning, my lamp, a long time no see. 4A was correct, yes. Now answer 5. I was you are not there for a long time in my lecture. I thought maybe you are busy in your lab exam, but then also you did not came. Okay, so one thing I told you, if you are seeing a graph based question and if you are not sure what is the answer, okay, there is only one option that you can guess. Remaining may be correct, may not be correct, but 90% chance is that that guess is correct, and that is this pattern. Okay, in this case also this is a correct answer, because magnetic field due to a current carrying straight infinite wire is proportional to 1 by r. Okay, mu naught by 2 I by r. So here we get 1 by r, it is proportional to 1 by r. So correct is inverse graph. Inverse graph is this one. Okay, so if you are in doubt, always answer this. If you are in doubt, in many cases, I will show you one more question which is very tricky and very difficult to answer if you try to answer it normally. Okay, so but you can guess that this is the correct option, right? Yes, my lamp. Now before I continue, just wanted to remind you ABHYAS KCET 2026 test series is available for your purchase. Here you are going to get 35 KCET tests along with KCET previous year 10 years previous KCET question papers as a quiz to you. All the questions from previous years will get you as in the form of quiz chapter wise, so that you, if you finish one chapter, you can practice previous year questions from that chapter as a quiz, and you can check how many of them you are able to solve them correctly. And not only that, the most important feature of our ABHYAS test series is the time. Okay, time management. So you are you have to answer 60 questions in 60 minutes, so that you are well prepared for KCET. So when the time comes before KCET, if you are attempting ABHYAS, you should be ready that okay, how many questions I am able to answer in 60 minutes. Am I able to answer 60 questions? That is the major thing that differentiates between a top 1000 rank and 1 lakh rank. So if you are really someone who want to score a rank below 1000, this is the ultimate test series, and the price is very nominal, 1499. Okay, hi Uday Kicha, after a long time, how are you? So you which college you are, you have taken admission? Are you repeating, or you have taken the admission? A moving electron produces only electric field, both electric field and magnetic field, only magnetic field, neither electric field or magnetic field. Okay, so moving electron produces both electric and magnetic field, both electric and magnetic field. A moving electron produces both electric and magnetic field. A coil having 9 number of turns, okay, BMSC CSC, wow, congratulations, good college and good subject as well. A coil having 9 turns carrying a current produces magnetic field B1 at the center. Now the coil is rewounded into 3 turns carrying same current, then the magnetic field at the center B2. 6B, yes, correct. Now this is a tricky question. So here we have a coil having 9 turns carrying a current produces magnetic field B1 at the center. Okay, so we have a coil. The number of turns here was N equals to 9. Okay, and it is producing a magnetic field B1 at the center. Magnetic field B at the center, B1. Okay, now what happened is that now coil is rewounded into 3 turns. That means if initially suppose the radius was R1, now what happens when you change the number of turns, okay, the radius will increase because number of turns is now decreased to 3. So if you are decreasing the number of turns, that means the radius has to increase. Okay, suppose the radius now is R2. The magnetic field now is B2. You have to find the relationship between B1 and B2. Very simple question. Only point in this problem is to find the relationship between R1 and R2. Okay, only point you have to find is basically relationship between R1 and R2. And also you know that magnetic field at the center of a current carrying wire is given by mu naught by 2 I upon R. Okay, mu naught by 2 I upon R is the magnetic field at the center. For at a distance it is slightly tricky. So basically what you can say, B1 by B2 is equals to R2 by R1. Okay, R2 by R1, or B2 equals to R1 by R2 into B1. Okay, so this is the formula, and if you can find R1 and R2, you can find the relation. So how to find the relationship between R1 and R2? Very easy. Here number of turns was 9. One more thing I forgot, it will be Ni. Okay, number of turns is also important over here. So it will be N by N dash. Okay, so it will be N dash by N. Okay, number of turns is also proportional, right? This is for one single loop. Now what? You have to find the R1 and R2. So initially total number of turns was 9. Each turn, what is the perimeter? Each turn the perimeter was 2 pi R1. So total number of total length of the wire was 9 into 2 pi R1. Now when you converted the same wire into 3, okay, the radius was R2. So each turn now have a perimeter of 2 pi R2. So total length is 3 into 2 pi R2. Okay, these should be equal because you are not cutting or changing the length. So these should be same. So 2 pi cancels and you get 3 3 is 9. So 3R1 equals to R2. So R2 equals to 3R1. So just put the values. So N dash is 3, N is 9, and R1 is R1, R2 is 3R1. So R1 cancels and you get 3 3s are 3. So it will be 1 by 9 B1. So it will be 1 by 9 B1. So correct answer is option A. Okay. Yes, my lamp, it is a tricky question. Thank you, Uday. We miss you. All the teachers always talk about Uday Kicha. How we all miss some of our students. Like right now, my lamp is one of our student who is attending regularly. So those who are wondering, Uday Kicha was one of our regular student, along with some other students as well. One name I remember, Shagufta. Okay, then. Kanchan, Shankar, those students used to come every day and they did well. We know many of them actually shared their ranks with us and we generally miss them. Now my lamp is obviously one of the students who is attending regularly. One student was there, few more students used to come in my lecture. Last time two students used to come. Nagraj was one of them. I don't know what happened to Nagraj. He's not attending lectures anyway. I hope he will come back after his board exams are over. Now question number 8. A particle of specific charge Q by M equals to, so understand, you understood my lamp this question. This is a very tricky question but not very difficult. If you understand that magnetic field at the center of a current carrying loop is given by this, okay, the formula is very simple, mu naught by 2 I by R. Now because they have n number of turns, that n has to be included in the formula, okay, and then just divide it. Don't try to find the magnetic field for both cases, that will very long. Directly from this formula you should get the proportionality formula, and from there you just need to put the values and calculate it. Okay, now also one more thing, if you are changing the size of the loop, then radius also changes, and based on that you will get, generally it will be one suggestion I can give, one formula that you can use. If obviously this same problem will not be repeated, similar problem will also not be repeated. In case you see such problem, okay, the new magnetic field at the center, is 1 by the ratio of the turns, that is 9 by 3, okay, whole square into B1. Okay, this is the shortcut simple formula, but this formula is only this particular problem specific, so it may not be helpful for you if you are not getting the same question. Okay, so better remember the fundamentals. Based on this formula you might see another question, but based on this same concept you may not see the question. Okay, so that is why I always say the concept repeats, not the exact question. So this concept, what is the relationship, what is the magnetic field at the center of a coil, that concept has come multiple times, but rewinding of the wire only once it came in 2024. Now next question. A particle of specific charge Q upon small m equals to pi coulomb, pi per kg, is projected from the origin towards the positive x-axis with the velocity 10 meter per second. This is also very tricky question. Okay, in a uniform magnetic field, B is equal to minus 2k T. K Tesla actually. 2k means in that vector along the z-axis, and T is Tesla. the velocity v of the particle after time t equals to 1 by 12 seconds will be. Now here what is happening, let us understand that. So here we have a magnetic field which is along the negative z axis. It is along the negative z. Okay, a particle with velocity is moving in the x direction. Okay, this is the x direction, it is moving in the x direction. So what happens is that, so particle experiences a force which is in the direction which is perpendicular to both of them. Okay, the particle is experiencing a force which is perpendicular to both of them, and it is rotating in a circular motion. So this is not ellipse, this is circle, because I am drawing a three-dimensional figure into a two-dimensional plane. It might appear to be an ellipse. Okay, so basically what happens, this is the velocity, this is the magnetic field, so it is rotating in this plane. So after some time t, okay, that 1 by 12 second, if this angle is theta, then the velocity's magnitude will be same, which is still acting along this direction, suppose. Okay, so if you know this angle theta, then velocity will be v cos theta I cap plus sin theta j cap. Okay, because if this is the theta, then this will be I cap component, and y cap or j cap component will be on the other axis. Okay, that is because that another axis is not shown over here. So if you take that component, it will be that y component. Okay, this is the y axis which is perpendicular to both of them. So because of z and x, it will rotate in like this, and you have to find this combination. Okay, so theta you have to calculate. How to calculate theta? To calculate theta, first of all, you have to find the time period, or you can do two things. Either you can calculate omega, and from there omega t is the theta, that is one way, or you can calculate time period, and from there you can also calculate the angle. Okay, so time period, I am choosing time period because that will give me an angle in terms of pi. So time period is given by 2 pi m by qb. This is the formula for time period. Time period means what? Time period of the rotation means it takes that much time to complete one oscillation. It takes that much time to complete one oscillation, one complete rotation. So one complete rotation means pi plus pi. So total angle traveled in this time is 2 pi. Okay, so 1 by 12 second, how much angle is traveled? That must be t by 12. Okay, so the angle traveled will be t by 12 into 2 pi. Okay, so it will be what mistake I am making? No, I am not making any mistake. It will be t pi by 6. T pi by 6 will be the angle traveled by the object. Okay, now you can do the same method for omega also. Omega is also fine. Anyway, I should have done omega method anyway. Let's see. So 2 pi m by qb is the time period. So what is the time period? Let us calculate that. Time period is given by 2 pi into magnetic field B is 2 Tesla. Okay, so magnitude only, the negative sign indicates the direction and the rotation, but here magnitude is sufficient, so B is 2. Now Q by M is pi, so M by Q must be 1 upon pi. M by Q must be 1 upon pi. So 2 pi cancel, so time period is 1 second. So in 1 second it goes by a distance of 2 pi degrees. So in 1 by 12 second it will travel by an angle of 1 into pi by 6, that is 30 degrees. So angle traveled in 1 by 12 second is 30 degrees. So V equals to cos V velocity vector equals to magnitude of velocity, that is 10 centimeter, cos 30 I cap plus sin 30 j cap. Okay, so 10 into root 3 by 2 I cap plus half j cap. Now half will be common and you get 5 root 3 I cap plus j cap. Again, this is a very tricky question. Correct answer is option C. Smile is saying final exam videos. Final exam videos will come very soon. Final exam video Smile will come very soon. Don't worry. Right now you still have some days to left, and if you still want to study, we have already started Masterstroke. You can check Masterstroke for your chapter wise preparation, and if you just want the questions, Brahmastra series we have done at least 3 months back. Their chapter wise all important questions are discussed. Now we are going to do long marathon videos very soon, so don't worry. We will provide you all the last minute suggestions, all the important questions and numericals through 3 markers, MCQs, everything will be discussed. Okay, don't worry. Okay, now next question. The magnetic field at the center of a circular coil of radius capital R carrying current I is 64 times the magnetic field at a distance x on its axis from the center of the coil. Then the value of x is. So this is again, as I mentioned, the concept keeps on repeating. The exact formula may not be repeated. So magnetic field at the center of a coil is given by mu naught by 2 I upon R. Okay, magnetic field at a distance x from the center is given by mu naught by 2 I R square divided by R square plus x square to the power 3 by 2. Okay, so this is the formula. So these two formulas, anyway this derivation you are doing, so this formula you should remember, and if you put x equals to 0 you get this equation. Okay, so now it says that B at the center is 64 times B at the distance x. Okay, now mu naught by 2 are constant, so definitely they will cancel. I is also constant, that will also cancel, so we can write 1 upon R, cancelling this and this, we can say 1 upon R equals to 64 times R square divided by R square plus x square to the power 3 by 2. Now slowly you have to improve your standard. Okay, stop writing entire equation when you know that okay I have to only write these quantities. Okay, now you need to do the cross multiplication and you get R square plus x square to the power 3 by 2 equals to 64 R cube. So if you take cube root on both sides, you get R square plus x square to the power half equals to 4R. Now take square on both sides. If you take square on both sides, you get R square plus x square equals to 16R square. Right, 16R square. So you get x square equals to 15R square, or x equals to square root of 15R. So correct answer is square root of 15R. Option D is correct. Right? Yes. Sri Short and Mylam both have answered correctly. Next, the torque acting on a magnetic dipole placed in uniform magnetic field is 0 when the angle between the dipole axis and the magnetic field is. So torque acting on a magnetic dipole placed in a uniform magnetic field is 0. So torque acting between electric field and magnetic field, if you remember electric and dipole, then also it is fine. If you don't remember, then magnetic field, if you don't remember the torque acting on a magnetic field, then you can recall the torque acting in electric field, which is given by PE sin theta. In case of magnet, this is electric field. For magnetic fields, the same torque is given by MB sin theta. Right? P is dipole moment. In case of magnet, dipole moment is M. E is electric field. For magnetic field, is given by B. So MB sin theta. So theta is basically same. So it is proportional to sin theta. So when the torque will be 0? Torque will be 0 at theta equals to 0 degree or theta equals to 180 degrees. At these two angles, the torque will be 0. So correct answer here, torque is 0 at an angle theta 0. Yes, correct, my lamp, Rehan, all of you have answered. Sri short, why C? Angle C, sine 90 is 1. Here we are talking about torque, not potential energy. Potential energy is 0 at 90 degree. Torque is 0 at 0 degree or 180 degree. Okay, torque can be 0 at 180 degrees or 0 degrees. 0 degree is stable equilibrium, 180 degree is unstable equilibrium. Okay, now let's move on. Which of the following statement is true in respect of diamagnetic substances? Permeability is greater than 1000. Susceptibility decreases with temperature. Susceptibility is small and negative. They are feebly attracted by magnet. Feebly means weakly. Feebly means weakly. Okay, they are feebly attracted by a magnet. So which one is correct? Which one is correct for question 11? Permittivity is greater than 1000. Susceptibility decreases with temperature. Susceptibility is small and negative. They are feebly attracted by magnet. By anyway, the variation of susceptibility, relative permeability with temperature, that portion is not part of the syllabus, but still one of the option was given in 2025. Fortunately, that is a wrong option, so that's why it was not created any craze. Okay. So yes, now the answer is option C. Susceptibility is small and negative. So the temperature variation of susceptibility with for diamagnetic substance or any substance is no longer part of the syllabus. For diamagnetic, it is proportional to temperature. Okay, for paramagnetic, it is inversely proportional to temperature. Universal property among all substance is diamagnetism, paramagnetism, ferromagnetism, non-magnetism. Which is universal property? Now, as I mentioned, some of the questions that used to come from this chapter, Magnetism and Matter, are now already deleted. So I am taking some questions maybe from your PU board exam, some questions I have taken from old KCET exam. So this is, I think, more than 10 years old. So that's why these questions are, I am not very sure about the years. So I have skipped the year. Okay, answer it. Yes, universal property among all substances is diamagnetism. What is the meaning of that? So all substances, including paramagnet and ferromagnet, they have some diamagnetic property in them. Okay, so because their ferromagnetism is so strong that diamagnetism does not show up. In case of ferromagnets, the ferromagnetism property is so strong that diamagnetism is completely suppressed. Similarly, in case of paramagnets also, the property of paramagnet is so strong that it suppresses the diamagnetism. Okay, so diamagnetism is common for all substances. Okay. Which of the following statement proves that Earth has a magnetic field? Earth is surrounded by ionosphere. The intensity of cosmic rays stream of charged particle is more at the poles than at the equator. A large quantity of iron ore is found in the Earth. Earth is a planet rotating around north-south axis. So what is the property that shows the magnetic nature of Earth, which shows magnetic properties of Earth? One thing could have been in this option, if it was there, if you hang a magnet, it points in the north-south direction. That could have been the explanation that, okay, north-south direction means definitely Earth is a magnet, but that option is not here. A proton and an alpha particle enter the region of uniform magnetic field at right angles to the direction of the field with same velocity. Which particle describes greater circular path? I saw this question somewhere, please answer. I had a doubt. I must personally answered this question in one of my lecture. I think during my 0 to hero series I answered it. So here let me go back to this concept. Okay, let me go here. So we have an alpha particle and a proton, right, or electron. Proton, okay, alpha particle and proton both enters the magnetic field with the same uniform magnetic field at right angles to the direction the field with the same velocity. So radius is given by mv divided by qb. Okay, radius is given by mv by qb. Okay, so radius of alpha particle is given by 4 MP. Why 4 MP? I will explain just a second. Radius of alpha particle is 4 MP into velocity divided by charge of an alpha particle is 2 into E into B. Magnetic field is same, velocity is same, so it will be 2 into MP V by EB. Okay, now what about the proton? The proton has mass MP, velocity V, charge E and magnetic field B. So R alpha is twice of that of proton. Okay, R alpha is twice of that of proton. Now from this concept there are multiple ways you can form a question. For example, kinetic energy is same, momentum is same. What will happen? Kinetic energy is same, both having same momentum, both having same kinetic energy. Alpha particle, proton and deuteron. So that was also came in the exam. Okay. Now what is more important is that mass of an alpha particle basically has two protons and two neutrons. So its mass, and if you assume that neutron's mass is very close to that of proton, so we can say that mass of alpha particle is 4 into mp. Okay, charge of alpha particle is doubly positive helium ion, so it is basically its charge is 2e. Okay, and in case of proton, single proton, mass is mp, only one proton, mass is mp and charge is e. Okay, so from this relation you can find the relationship between alpha and p. Similarly, if you are asking about deuteron basically is a isotope hydrogen having one proton, one neutron in the nucleus, okay, and only one electron orbiting around it. Now if you take that electron out, it becomes a deuteron ion. Okay, deuteron ion means it has one positive charge and twice of the mass. Okay, in that case deuteron will have again deuteron will also have the radius more than that of proton. Okay, mass is twice that of proton, but charge is same as the proton. So again alpha and deuteron will have same radius. Deuteron means H12. Okay, this is called deuteron. Okay, so it has one proton, but one proton and one neutron. Okay, now clear lamp. Mallukolli sir, NEET preparation madide KCET clear agutta. Okay, no, even though you think that if you prepare for NEET KCET will be cleared, actually no, KCET do require a time based preparation. Okay, NEET questions are slightly trickier, but you only need to answer 45 questions. In KCET you have to answer 60 questions. Okay, you have to answer 60 questions, and to answer those 60 questions only 60 minutes are there. Okay, NEET exams 45 questions in 60 minutes. I think no, NEET also 45 questions in 45 minutes only, but biology is there which takes two parts of NEET, 45 plus 45, 90 question comes from biology and 90 question comes from physics and chemistry. So KCET level questions are slightly trickier than NEET question in some sense, because you get a lot of time saved while answering biology questions. Biology questions are little bit easier to answer than in KCET you are only focusing on physics. Okay, in NEET question you have to manage the time. First you try to answer all the bio questions, because bio questions are direct. You don't need to only maybe one or two questions, or maybe few questions where you have to apply some formulas, some calculations, but otherwise most of the questions are straightforward. You know it, you answer it. You don't know it, you leave it. Okay, in chemistry and by physics you have to use your brain, but the level of difficulty in NEET is slightly different than that of KCET, right? So if you think that if I make you prepare for NEET and your KCET will be prepared automatically, it is actually not correct. Which of the following statement proves that Earth has a magnetic field? So as I mentioned, some of you have answered. Rehan answered is option B. Option B is correct. Okay, option B is correct. The intensity of cosmic ray stream of the charged particle is more as the pole than the equator. Earth surrounded by ionosphere does not prove that Earth has a magnetic field. There are some planets, they do have ionosphere or had ionosphere in the past, but that does not prove that Earth has a magnetic field. But the cosmic ray particles which are attracted by the magnetic pole, because when the cosmic ray particles are charged particle, okay, they are coming from space. When they are moving with speed, okay, they tend to attracted by the poles of the magnet, and that's why they concentrate near the poles. So this is the direct proof of Earth having magnetic field, not the ionosphere. Ionosphere is basically produced by ions, not by magnetic charges. In a paramagnet, in a permanent magnet, extremely sorry. In a permanent magnet at room temperature, domains are partially aligned, domains are all perfectly aligned, magnetic moment of each molecule is zero, the individual molecules have non-zero magnetic moment, which are all perfectly aligned. Ionosphere is a layer of atmosphere. Okay, so if you know that we are currently living in stratosphere, then troposphere, then ionosphere, then magnetosphere. Okay, magnetosphere is where the cosmic rays particles come and interact with Earth's atmosphere. Okay, ionosphere is a layer above troposphere. We are in stratosphere. We are in troposphere. Above troposphere is stratosphere. Stratosphere is static, where all the planes, the army aeroplanes and our normal navigational planes, they all travel in stratosphere, because it is a completely static, so planes can travel without much disturbance. Okay, troposphere is the region where we are all tropical atmosphere we are observing. Okay, for example, the rains, the weather change, everything happens in troposphere. So on top of troposphere we have stratosphere. On top of stratosphere is ionosphere. Ionosphere is consisting of all the molecules present in ionosphere, they are all ionized. Okay, and it is used for communication, space communication. Okay, so initially in the past, when we were using we do not have any satellites. Okay, we want to send a signal from one place to another. There is one way, either you send it via wires or you send it via ionosphere. Okay, the telephone communication, the radio communication, that used to happen through ionosphere. Still now it happens. So if you see that there is a spectrum allocated, the spectrum is basically a region in ionosphere. Okay, so basically they resonate with that frequency, and you can transfer the wave if you are transferring it through air. If you are transferring it through cables, that is fine. But if you are transferring it through air, then the region through which it is gone, it is basically the ionosphere. Ionosphere, what happened? Numanandar. Previous question in simple. Which question? This one. Numalandar, which question? Numan Inamdar. Numan Inamdar. So if you see that this is the earth, okay, so here we are in troposphere, this is the earth, this is troposphere, and on top of that we have stratosphere. And on top of that we have ionosphere. In ionosphere, all the gases exist in ionized form, okay. So for example, if you consider water, very simple, so here water exists in H plus and OH minus molecules, and this does not have, this is nothing to do with your Earth's magnetic field. Why the ionization happens? Because high energy particles comes and interact with the molecules present there, and they split them into ions. It has nothing to do with Earth being a magnetic or non-magnetic, okay. So, and if you consider the cosmic ray, that is high energy particles, they, when they comes, okay, they interact more near the poles, okay. Why near the poles? Because the north and south pole, the north and south pole of the Earth's magnetic field are located like this. So all the high energy particles, when they come, they are moving towards the pole, okay, because moving particles, they produce magnetic field of their own, and that magnetic field and this magnetic field, they interact with each other and they start attracting, and that is why you see aurora borealis and aurora Coriolis on northern light and southern light. What happens is that when the high energy particles comes through our atmosphere, they break the molecules present there into ions, okay, and those ions produce a light, and that light is observed only on the northern pole and southern pole, okay. So you can say that the polar lights is also a symbol that Earth is a magnet. Clear? Right? So because this moving charge particles, they are moving, they produce a magnetic field, they interact with Earth's magnetic field, and they produce lights only on the northern and southern poles, okay. So that is the cosmic rays. Cosmic ray means particles, high energy particles. Cosmic ray is not electromagnetic wave. Cosmic ray means high energy charged particle, electron, proton, neutron or ions, okay. They are all coming from stars, and our universe is filled of cosmic rays, okay. Radiation is one thing, and cosmic particles, cosmic ray means they are moving particles, high energy particles. When they interact with Earth's atmosphere near the pole, we see northern lights and southern lights. So there was once a question which asks that which of the following is a proof of Earth's magnetic field. One option was given, northern light and southern light, or aurora borealis, aurora Coriolis. Okay, aurora borealis is happening because of Earth is a magnet. Okay, one more important thing, that solar particles, the high energy particles that is coming from sun, actually, which burned our moon into barren land, or which creates the Venus. Okay, Venus is almost Earth-like planet, but it is, instead of having a atmosphere and life on Earth, Venus is a hot planet. That is also because Venus does not have its own magnetic field. That is one of the reason. Okay. So in a permanent magnet at room temperature, domains are partially aligned, domains are all perfectly aligned, magnetic moment of each molecule is 0. The individual molecules have non-zero magnetic moment, which are all perfectly aligned. Which question is correct? Quickly answer it. So permanent magnet at room temperature, domains cannot be perfectly aligned. Domains are always partially aligned. Domains are always perfectly aligned, and in fact if you read the options, domains are perfectly aligned and domains are, this option both remain same. Okay, and individual molecules have non-zero magnetic moment, and they have actually forming the domains, and those domains are not perfectly aligned. Okay, domains are only partially aligned. If you decrease the temperature below certain point, then you can get as maximum alignment of the domains, but at room temperature, because there is a vibration present in the molecule, so domains cannot be perfectly aligned. Domain means what happens if you are considering a ferromagnetic material. If you are considering a ferromagnetic material, okay, all molecules present in a ferromagnetic material, they are all having their own magnetic field. Okay, they all have their own magnetic moment. Magnetic moment means, suppose this is the nucleus, an electron is orbiting around the nucleus. When the electron is orbiting around the nucleus, because it has a up spin or down spin, based on that, okay, the molecule or the atom itself will have a magnetic moment if the electron is single, or lone pair. Okay, single electron, if the electron is single, then that electron will produce its own magnetic field, and that magnetic field, when you are considering in a bulk material, this is atom, one single atom. In a bulk material, there are more than one atom. Obviously, thousands of atoms are there. Now, when you consider in an atom, what happens? Some zone or area, they all make a group. Okay, they all make a single group. They said, okay, we are together, we have to be united against all the external forces. So they say, okay, let us form a zone, and that zone is called domain. Here all atoms, they are aligned, they are all having same directional magnetic moment. Okay, suppose the all atoms present in this zone, they have a magnetic moment in this direction. Okay, but the nearest zone next to it may have a magnetic moment in a different direction. So in a magnetic material, all the atoms, they basically divide themselves into different magnetic moment. Okay, it can be like this, it can be like this. So they all divide themselves into different zones. For example, when you are in a classroom, okay, suppose, okay, he is my friend, she is my friend, he is my friend, he is my friend, we will all sit together. Whoever are not my close friends, I will not sit with them. They can do whatever they want in a separate plot, right? So we all do that. We hey, you know what we have to do? Especially boys, they used to talk about, okay, today after class we will play PUBG, okay, in his house. Girls say, okay, what web series have you watched? What are going to do after this class? Okay, what kind of makeups you have bought? So you discuss all these things in your class. So those students, 4 or 5 students, they form a zone. Okay, and all the classroom is basically scattered across all different zones. Okay, 5, 6, 7, 8 zones are there in a large classroom. So when the teacher enters in the classroom, all the students become silent. They start listening to the teacher. Okay, but are they all silent and are they all listening to the teacher? No, there are some variations here and there as well. So that means when the teacher is basically the magnetic field, external magnetic field. So when you apply external magnetic field, what happens? These zones, they all align, but they do not align perfectly, but partially. Partially means they are still listening to the teacher, okay, whatever he is saying, but we are still in our discussion mode. Okay, so the domains overall they align, but their alignment is not yet perfect. So overall magnetic alignment is in the direction of the magnetic field, but they still not perfectly aligned. Okay, now if you move the magnetic field, for a ferromagnet, the magnetism is retained. Okay, and again they are not perfectly aligned, the alignment is slightly off. So at room temperature means when you remove the external magnetic field and the temperature is not 0 degree Celsius, not 0 degree Kelvin, at room temperature it is about 30 degree Celsius. So at that temperature, domains cannot perfectly align because there is still a vibration present, right? Clear, Shaila? I think your doubt is clear. Domain means Now needles N1, N2 and N3, and you should watch my Magnetism and Matter Masterstroke video. There I have explained how the properties, why diamagnetism is occurring, why paramagnetism occurring, why ferromagnetism is occurring. I have discussed in detail in my Magnetism and Matter video. Do check that out. Okay, domains, everything I have explained there. Needles N1, N2 and N3 are made of a ferromagnet, a paramagnetic and a diamagnetic substance respectively. A magnet when brought close to them. So one of them is ferromagnetic. So needle N1 is ferro. Okay, needle N2 is para and needle N3 is dia. Now you brought a magnet, big magnet. What will happen? So a magnet when brought close to them attract all three of them, attract N1 strongly, N2 weakly, repel N3 weakly, attract N1 strongly but repel N2 and N3, attract N1 and N2 strongly but repel N3. So you, even if you don't read the question properly, by reading the answer you can answer yes. Most of you have answered it correctly. Attract N1 strongly, so it attracts this one strongly, attract this one weakly and repel this one weakly. Okay, now next question. The magnetic intensity to completely demagnetize a ferromagnet is 3 into 10 to the power of 3 ampere per meter. The minimum current required to be passed in a solenoid having 1000 turns per meter so that the magnet gets completely demagnetized when placed inside the solenoid. So magnetic intensity means the magnetic field. Ampere per meter is actually Tesla. So you require this much magnetic field to destroy a magnet. Okay. So not a magnetic field, H is equal to B by mu naught. So this is the magnetic intensity. You require this much magnetic intensity to destroy a magnet. Okay, and if you want to destroy the magnet, you are producing a solenoid and placing the magnet inside the solenoid to destroy it. Okay, so this H value is given 3 into 10 to the power of 3. Now when you are placing this inside a solenoid, the solenoid is producing a magnetic field equals to mu naught N I. Okay, mu naught N I. So mu naught N I divided by mu naught. So you get I equals to 3 into 10 to the power of 3 divided by 10 to the power of 3, that is only 3 ampere. Okay, so here they have mentioned that the number of turns is 1000 per meter. Okay, 1000 turns per meter. 1000 turns per meter means 10 to the power of 3. So 10 to the power of 3, 10 to the power of 3 cancels. So correct answer is option A. Simple but not super easy. Yes, Shaila, you are correct. Now next question. When a bar magnet is pushed towards the coil along its axis as shown in the figure, the galvanometer pointer deflects towards X. When the magnet is pulled away from the coil, the galvanometer pointer, so when you are pushing this magnet towards the coil, the galvanometer deflects towards X. So when you are pulling it away, the galvanometer pointer should point towards X dash, obviously, right? Very simple. So when you are pulling it, pushing it, it will point in the X. That means if you are pushing it, pulling it away, then it should point in the opposite direction. That is the Lenz's law. Okay, so it deflects towards X dash or X1 over here. So it deflects towards X dash. Yes, yes, correct. Short, which one you are saying? Option B, I am not sure. I think you are saying this case. It is not 30 milliampere, it is 3 ampere. Okay, because 10 to the power of 3 will be cancelled. Magnetism is magnetic intensity is given by 3 into 10 to the power of 3. So 10 to the power of 3, 10 to the power of 3 will cancel. Right? and if you are saying this is B oscillates, it is not possible. When you are either it will move, it will may oscillate for a few millisecond, but it will stop. As soon as if you are pulling it away, it will go in the opposite direction, and if you are stopping the magnet, the motion will stop after few vibration. Square loop of side 2 meter lies in the YZ plane in a region having magnetic field B equals to 5I cap plus 3J cap minus 4K cap Tesla. The magnitude of the magnetic flux through the square loop is. I am giving you 2 minutes time to solve it. I will have a glass of water, so I am very thirsty. Please solve it and tell me the answer for this question in the chat. Okay, Short is saying option A, Shaila is saying option B. So let's see, square loop of side 2 meter. So first of all, what is the formula for magnetic flux? Formula for magnetic flux is very simple, B dot A. B dot A, okay, BA cos theta, but here cos theta is not given, it is given in terms of vector, so you have to use B dot A formula, dot product. Okay, here the area is 2 meter square, so 2 meter square loop, so 2 into 2 meter square, that is 4 meter square. But this is scalar value. What is the direction? Lies in the YZ plane. So YZ plane means this is Y, this is Z, then the vector will point in the direction of X. Okay, YZ plane, if this is the YZ plane, the vector will point perpendicular to both Y and Z, that is in the X direction. So A vector will be 4I cap. A vector is 4I cap. So now put the value, 5I cap plus 3J cap minus 4K cap into 4I cap. Okay, YZ plane means I cap vector. XZ plane means J cap vector. XY plane means K cap vector. Remember this, okay? Whatever the plane is mentioned, the unit vector will be the other plane which is not mentioned. So XZ plane means X is not mentioned, so the unit vector will be in the X, I cap direction. Okay, now while doing dot product, only the similar products gets multiplied, remaining dot product becomes 0. So 5 4s are 20. So it will be 20 Weber. It will be 20 Weber. So now not 12, not 16, not 10, but 20. So option D is correct. So I guess most of you have got it wrong. Rehan, Short is correct. Rehan initially said C, then he changed his answer to D. Okay, Shaila was saying I think B, but it is not B, it is D. Okay, now let's move on to the next question. A uniform magnetic field of strength B equals to 2 millitesla exists vertically downward. These magnetic field lines pass through a closed surface as shown. Okay, so 2 millitesla is sufficient, and then the diagram is sufficient. So here it says that the magnetic field which is passing through this dome and this cone, conical shape, and this hemisphere, it is given by 2 millitesla. Okay, now what is the flux that is passing through this surface S1? What is the flux that is passing through this surface S2? Okay, the radius is given by 10 by root pi. Now this question came in 2024, but it was given as a bonus question because they forgot to mention this centimeter. Okay, because if you take this as meter, answer will be different, the unit will be different. Okay, this centimeter was not mentioned. Normally if nothing is mentioned, we generally take this as meter, but this R is given in centimeter units. Okay, that was not mentioned in the question, in the diagram itself. It was taken directly from the question paper. So as you can see, because centimeter was not mentioned, student in that year, they got benefits of doubt and they got the bonus mark. But if the centimeter is mentioned or meter is mentioned, units will be different, otherwise calculation will be same. So how to answer this question? Okay, so first of all, the answer is not very tricky. The diagram is given to confuse you. Only point is the diagram is given to confuse you. There is a hemisphere, there is a conical shape. Only thing you have to remember that for a magnetic field or electric field, because there is no charge or no magnetic field involved, no charge is there. So whatever is the incoming flux, same flux should go out. Same flux should go out. So the incoming flux should be equals to outgoing flux. Now incoming flux is taken as negative. Okay, incoming flux is taken as negative, outgoing flux is taken as positive. Why it is so? Remember positive charge, if you have a positive charge inside a sphere, the charge gives out electric field outside, right? So that is basically positive flux. If you have a negative charge inside, all the flux is coming into the surface, so that is a negative flux. Okay, so because similarly the concept of flux is coming from electric field and then continuing to magnetic field. Similarly, if the flux is incoming, then it is basically negative. If it is outgoing, it is positive. Okay, so that is why if you see both values are same. Okay, so incoming flux should be equals to outgoing flux. Now flux is given by BA cos theta, or if cos theta is 90 degrees, cos theta is 0 degrees, it will be simply BA. Now if you are using this surface to calculate your BA, you have to construct an integration, take a small value, do entire integration, and that will be very, very long process. But fortunately, because the flux is constant, whatever is incoming, whatever is same flux is outgoing, that means the same amount of flux is passing through this circular surface as well. This is the common surface for this hemisphere as well as the cone. Okay, so that is why instead of taking the hemisphere or taking the cone, we will take the common circular interface. We will take the common circular interface to calculate the flux. Okay, so flux is given by magnetic field into area, that is magnetic field is given by 2 millitesla, milli means 10 to the power of minus 3, and area is given by pi r square. Okay, pi r square is pi into r by 10 by root pi square, 10 by root pi. Now it is given in centimeter, that means 10 to the power of minus 2 whole square. Okay, centimeter to meter conversion is necessary, otherwise you will not be able to solve it. So pi into 100 divided by pi cancels, and 10 to the power of minus 4. So area is actually turns out to be 10 to the power of minus 2 meter square. Now put in this equation, you get 2 into 10 to the power of minus 5, or it will be 20 microweber. Micro means 10 to the power of minus 6. So 20 microweber. Incoming is negative, outgoing is positive. Okay, so correct answer is option A. Shahabuddin 1123. Short, it will be over in another 30 minutes, more than 30 minutes. Also, remaining questions are very, very easy. We will be able to solve them without much difficulty. 1 or 2 questions are slightly tricky, otherwise most of the questions are straightforward. So I was planning to close it by 7:30, but some questions came, and to explain those it took some time. Otherwise it would have been over by 7:30. So I will be trying to close it by 7:30 only. Let's see if you are answering it quickly. I will be close it quickly. In the figure, a conducting ring of certain resistance is falling towards a current carrying straight long conductor. The ring and the conductor are in the same plane. Then induced electric current is 0, induced electric current is anti-clockwise, induced electric current is clockwise, ring will come to rest. So let's see, here we have a current carrying wire which is carrying current, and the magnetic field due to a current carrying wire is is circular. So for this ring it is on the top, so the circular magnetic field will be out of the page. Magnetic field will be out of the page. And as it is coming towards the wire, the magnetic field value increases. Magnetic field value increases in this direction. Okay, magnetic field is out of the page and it is increasing. So increasing means the induced current in this loop, it will try to reduce the magnetic field by producing a magnetic field which is opposite direction. Okay, so it will try to produce a magnetic field which opposes this outgoing magnetic field. So the direction of current in this loop will be particularly in this direction. So the current induced in this loop will be in this direction, so that it can reduce the effect of increasing magnetic field. So the current induced in this loop in clockwise direction. It is in clockwise direction. If the magnetic field is decreasing, then it would try to increase the magnetic field, then it would have produced the magnetic field in the clockwise direction. Because it is falling towards the wire, then it will be clockwise direction. If it is falling away from the wire, it will be in the anti-clockwise direction. Be careful. Okay, because magnetic field is increasing, it will try to reduce it, so that's why it will produce a magnetic field in the opposite direction, and that is why it will be producing a magnetic field which opposes the motion. Extremely sorry. It will try to reduce the magnetic field. That means induced magnetic field in the opposite. Okay, sorry, my mistake. It will be correct. It was correct. Current in this direction means magnetic field is into the paper. Yes. Now next question. An induced current of 2 ampere flows through a coil. The resistance of the coil is 10 ohm. What is the change in magnetic flux associated with the coil in 1 millisecond? Okay, so induced current is 2 ampere, flows through a resistance of the coil 10 ohm. What is the change in magnetic flux associated with it in 1 millisecond? So induced EMF is change in magnetic flux divided by time, d∅ by dt, right? Negative sign is there. So magnitude of induced EMF is d∅ by dt. So what is the induced EMF? Current is given, resistance is given. So induced EMF is V is equal to IR. Induced, even though we say induced EMF, it is basically a voltage. It is basically a voltage. So epsilon is always I into R. Okay, so I into R. So don't be confused or don't think this is a difficult question. Actually, it is an easy question. So induced EMF is 20 volts. To 20 volts equals to d∅ by the time given here 1 millisecond. 1 millisecond means 10 to the power of minus 3. Milli means minus 3. So change in flux is 20 into 10 to the power of minus 3. That is 2 into 10 to the power of minus 2. So change in flux is option B. Yes, Shaila, I think you are perfectly correct. Okay. Rehan also correct. Option B. Shaila, why you changed your answer to A? Why you changed your answer to option A? You answered it B. Then you changed your answer to wrong option A. No, option B is correct. 2 into 10 to the power of minus 2. Option A is 0.2 into 10 to the power of minus 2. Right? 10 to the power of, here it was 20 volt. 20 into 10 to the power of minus 3 means 1 0 you have adjusted, you got 2 into 10 to the power of minus 2, right? Now next question. Short switch answer, yes, option C. Option C, why option C you are answering? So all of you are answering some random options. I am not sure why you are doing that. Anyway, this is a very interesting question. A square loop of side of length small a is moving away from an infinitely long current carrying conductor at a constant speed v as shown. Let x be the instantaneous distance between the long conductor and side AB. The mutual inductance M of the square loop long conductor pair changes with T according to the which of the graphs. So let us understand this question. Here is a current carrying wire, here is a loop. Okay, the loop is being transferred in this direction. So how does the mutual inductance, it is not talking about induced current, it is talking about mutual inductance between this wire and this loop, how does it change? Now if you want to try to derive it mathematically, it would be a very, very difficult method. Okay, formula is not very simple, derivation is also not very simple. So either you can use one trick that I told you. If you don't know how to answer a graph based question, then the correct answer 90% chance is it is an inverse square graph. So by that logic you can answer it, and in this case as well this is the correct answer. Okay, but if you want to solve it little bit more wittingly, then if you see that the distance x and this mutual inductance between the current carrying wire and this loop has to be linked. Okay, so as you are moving away from the current carrying wire, the mutual inductance must decrease. Okay, so as you are moving away from this, the mutual inductance should decrease. So mutual inductance must be inversely proportional to the distance x. Now how does x changes? You are plotting a graph mutual inductance versus time, not x versus m. So how does x is related with time? So for that the velocity is given. So velocity of an object is given by, distance traveled by an object is given by velocity into time, right? S is equal to ut plus half at square. A is not 0 here, acceleration is not there. So mutual inductance must be proportional to time 1 by t. Okay, so that's why it will be an inverse square graph. Now exact derivation is not simple ln, there will be a logarithmic to the base e will come, and you have to derive one formula and then you have to solve it. That is a very long process and obviously out of syllabus. But the logic is that as you are moving away from a current carrying wire, the mutual inductance should decrease, and here the relationship between distance and speed is x equals to vt, so m must be inversely proportional to time t as well. Okay, so correct answer is option A. Why mutual inductance decreases theoretically? So mutual inductance, basically closer they are, so closer two coils are, or to closer two objects are, more number of field lines can. Suppose we have one coil over here, actually it is more between coil, it can be expressed between a current carrying wire and a loop as well. So the field lines which is basically produced by, suppose this is the field lines produced by the wire 1. Okay, and because of this field line produced by the wire 1, it is linked with the wire 2, and that linkage produces a current in the second loop. Okay, in this particular given problem, current carrying wire and the loop which is moving, the magnetic field lines is stronger near the, magnetic field lines was stronger near the wire. Okay, magnetic field lines was much stronger over here into the page. So magnetic field lines was stronger, but as you are moving away, the magnetic field lines becomes weaker. Okay, magnetic field, weaker magnetic field means less number of field lines getting attached with this loop. and less number of field lines getting attached means the induced EMF also slowly decreases. Okay, so mutual inductance basically gives the current flow. If induced EMF is equal to M into di by dt, right? Induced EMF, if you remember, induced EMF was mutual inductance into rate of change of current. Okay, now as you are moving away, the linked magnetic flux decreases, and as the magnetic flux decreases, the mutual inductance also decreases. So mutual inductance basically constant for a given distance, but as the distance increases, the more and more less number of magnetic field lines is linked. So less number of magnetic field lines linkage means the mutual inductance also decreases. Okay, so mutual inductance is basically when the field line emitting from one loop, how they are linked with the second loop. If more number of magnetic field line is linked, so suppose we have one loop, so magnetic field produced by this loop, okay, as you are moving away and away, okay, magnetic field lines getting weaker, and you are coming close and close, magnetic field lines becoming stronger. So if your second loop is closer to the first loop, okay, the more and more field lines can cross through the loop. More and more field lines can cross through the loop. Stronger the magnetic flux linkage, stronger is the mutual inductance. More line passing through this loop means stronger or higher mutual inductance. If less number of lines is passing through the loop, if less number of magnetic field lines passing through a loop, that means the mutual inductance is low. So for example, here mutual inductance between these two loops is much higher than mutual inductance between these two loops. Okay, closer the loops are, more number of field lines can pass. More number of field lines can pass means stronger is the mutual inductance. Okay, got it? The current in a coil changes from 2 ampere to 5 ampere in 0.3 second. The magnitude of EMF induced in the coil is 1 volt. The value of self-inductance in the coil is. So induced EMF is L di by dt. Okay, so induced EMF is given here 1 volt. L we are trying to find. Di is 5 minus 2. And dt is 0.3. So it will be L into 3 by 0.3, that is 10L. So L equals to 0.1 Henry. So it will be 0.1 Henry, or because 1 Henry, 0.1 Henry is not given, it will be 100 millihenry. Okay, milli means 10 to the power of minus 3. Okay, so 100 into 10 to the power of minus 3 means 10 to the 0.1. Okay, so it will be 100 millihenries. Those who have answered option A are correct. Shaila, short. Which one? Why not D? This one, or are you saying this one? This is also decreasing, but here the decrease is happening inversely. Okay, inverse proportionality. Inverse proportionality means it will be a non-linear graph. Here it is a linear graph. Okay, so that is why it is only option A, not option D. Okay, so non-linear graph, it is inverse proportional graph 1 by t. So this is the inverse proportionality graph. This is simply decreasing, negative graph, negative slope. Okay, so minus x. If it is minus t, then this graph is correct. But it is 1 by t, so that is the reason it is correct. Now next, question number 24. A metallic rod of length 1 meter held along east-west direction is allowed to fall down freely. Given the horizontal component of Earth's magnetic field BH equals to 3 into 10 to the power of minus 5 Tesla, the EMF induced in the rod at an instant t equals to 2 seconds after it is released. Okay, so a rod is released from rest in a magnetic field, horizontal magnetic field. So east-west direction, and horizontal magnetic field is given like this. Horizontal magnetic field is actually not in this direction, it is in north to south direction, obviously perpendicular direction. So the rod is falling through this perpendicular magnetic field, and that is given by 3 into 10 to the power of minus 5 Tesla. So what is the length is 1 meter. What is the induced EMF? Induced EMF or motional EMF is B into V into L, BVL. Now here if you see that velocity is not given, but what is given? Time is given, and it is allowed to fall freely from rest. So freely from rest means it is moving under the action of gravity. Obviously if you drop something, after some time it gains a velocity, and that velocity is given by G into T over here. G is gravitational acceleration, T is time. Even the question G is value is given, G is 10, T is 2 seconds, then the speed gained by the object is 20 meter per second. So put that value over here. Magnetic field B is 3 into 10 to the power of minus 5, velocity is 20, and length is 1 meter. So it will be 60 into 10 to the power of minus 5, or 6 into 10 to the power of minus 4. 6 into 10 to the power of minus 4 volt. Right, option D. Right, let's move on to question number 25. Another interesting question. A square loop of side 2 centimeter enters a magnetic field with a constant speed of 2 centimeter per second as shown. The front edge enters the field at t equals to 0. Which of the following graph correctly depicts the induced EMF in the loop? Okay, option A, option B, option C, or option D. So here we have a loop which enters the magnetic field. Okay, now there are one or two ways to answer it. So as this loop is approaching this magnetic magnetic field, there will be an induced EMF. Okay, here it is mentioned that clockwise direction is positive. Clockwise direction is positive. So here the magnetic field is into the page of the paper. So the induced EMF will be in this direction. Induced EMF will be in this direction initially. So induced EMF will be in the anti-clockwise direction. So initial approach, when it is entering the magnetic field, the initial magnetic field induced in the loop will be negative. Initial induced magnetic field will be negative. Now when it is leaving the magnetic field, now the magnetic field is decreasing. So in this particular case, the magnetic field will be produced in the opposite direction. So that is positive. Okay, so magnetic field will induce 2 times. When it is entering, magnetic field value increasing, that means it will produce a current in the anti-clockwise direction, okay, such that it opposes the motion, and when it is leaving, so it will produce a magnetic field in the direction of magnetic field, so that it is positive. Clockwise is positive, anti-clockwise is negative. So from the given graph, we can say that you don't need to do any calculation is not required. So initially it is negative, finally it is positive, and when it is entering it is constant, when it is leaving again it is constant, in between it is 0. So that means correct answer is option D. Correct answer is option D. Yes, Shaila, not option C but option D. This is not correct, this is not correct. Okay, and it is not gradually increasing when it is entering, because of the speed, constant speed, the initial magnetic field entering each second is constant, and that is why the induced magnetic field is also constant. When it is completely inside, magnetic field change is 0, so no magnetic field is induced, so in between it will be completely 0. When it is leaving the magnetic field, what happens is that again it is leaving one by one, each time uniform change in magnetic flux. A uniform change in magnetic flux means it will give you a constant magnetic flux. Now Next question. A long solenoid has 500 turns. When a current of 2 ampere passed through it, the resulting magnetic flux linked with each turn of the solenoid is 4 into 10 to the power of minus 3 Weber. Then the self inductance of the coil is. So here number of turns is 500, current passing through is 2 ampere. Okay, result in magnetic flux linked with the solenoid is 4 into 10 to the power of minus 3 Weber. So we know that B equals to mu naught Ni. Okay, mu naught Ni is the magnetic flux. Okay. So let's see, induced EMF is given by d phi induced EMF is given by d phi by dt, whereas in terms of self-inductance it is given by di by dt. So from here we can say the flux linked is equals to L into I. The flux linked is equals to L into I. So d phi equals to L into di, or flux linked equals to L into I. Okay, so from here self inductance is basically phi by I. So this is a EBHYAS question. So if flux is given, the number of turns is given, so here it will be N, obviously. N phi here, N will be here on the side of phi. Okay, current, for current it does not matter, only the change in current matters, not the number of turns. So from here we can say that the self inductance is given by N is 500. Okay, phi is 4 into 10 to the power of minus 3, and the current is given here 2 ampere. Okay, so you cancel 2 4 4 2 are 2, so you get 1000 into 10 to the power of minus 3, that is 1 Henry. So the correct answer is 1 Henry. Yes, option C is correct. Next, match the following with types of waves with their wavelength ranges: microwave, visible light, ultraviolet, X-rays. Question from 2025. So visible light ranges from 700 nanometer to 400 nanometer. So 2 is matching with option A. 2 is matching with option A. Right? Now what about ultraviolet and X-ray? Ultraviolet starts where visible light ends. Okay, so visible light's minimum wavelength is 400 nanometer. So ultraviolet starts from 400 nanometer. So ultraviolet is 400 to 1 nanometer. So this is ultraviolet. So option D is ultraviolet. Whereas X-ray starts from where ultraviolet ends. So X-ray basically 1 nanometer to 10 to the power of minus 3 nanometer. So X-ray is B. Okay. Microwave is after infrared ray. So this is 0.1 meter to 1 millimeter. So remember, microwave has higher wavelength than all of them. So microwave is basically matching with this, then visible light, then ultraviolet light, then X-ray. So from there, this logic also you can answer. So correct matching is 1 with C, 1 with C, 2 with A, 3 with D, and 4 with B. So correct match is option D. Next question. The ratio of magnitudes of electric field to magnetic field of an electromagnetic wave is in the order of. Easy question. Madhi Kanum is option D. Correct answer, everyone. Rehan, Shaila. Answer this quickly. So here the ratio of magnitudes of electric field to the magnetic field of an electromagnetic wave is in the order of 10 to the power of 8 meter per second. Okay, because electric field to magnetic field is basically the speed of light. Speed of light is 3 into 10 to the power of 8. So the order is 10 to the power of 8. If the question is magnetic field to electric field, then it would be 10 to the power of minus 8. Right? Yes. Short is short, not B. Short, it should be option C. It is C option. Next, which are you saying the previous question? Previous question D was correct. This one is option C. Sir, in physics I am getting almost full marks in theory, but in MCQ I am losing marks, too many marks. So I will bring you all MCQ questions, and also I will give you strategy how can you answer MCQs perfectly. So please be patient for 1 or 2 more days, 1 week. Next week we have certain things that is planned. So after 3-4 days we will be definitely bring you more details about all MCQs. I will basically make one strategy video where all the MCQs answering techniques I will discuss, and in another video where I will discuss all the MCQs. So that there, if you want the answers, then you can get. Also, if you don't know MCQs, how to tackle those unknown MCQs also I will give you. So don't worry. Please be patient. Which of the following radiations deflected by electric field? Gamma ray, X-ray, alpha particles, neutrons. Which of the following radiations deflected by electric field? Gamma rays, X-rays, alpha particles, neutrons. Yes, Madhikanum, yes, correct answer was option C. Nikhil, I mentioned how to help you. Hi Sanjana. Sanjana, you are late today. Shorts is saying option D, neutrons. Which of the following radiations deflected by electric field? If something is deflected by electric field, that means it must be charged. Gamma ray is a high energy radiation. X-ray, high energy radiation. Okay, neutrons are electrically neutral. So only left with alpha particle. Alpha particle is nothing but He++ or He+2. Okay, so it is a doubly positive helium ion. That means only helium ion will be deflected by electric field, not gamma ray, not X-ray, not neutrons, only alpha particles. Okay, so option C is correct, not option D. Now answer this question. Suppose that the electric field amplitude of electromagnetic wave is E0 equals to 120 Newton per Coulomb, and its frequency is F equals to 50 megahertz. Then which of the following value is incorrectly computed? Very tricky question. Magnetic field amplitude is 400 Tesla. Angular frequency of electromagnetic wave is pi into 10 to the power of 8 radian per second. Propagation constant angular wave number is 2.1 radian per meter. Wavelength of electromagnetic wave is 6 meter. Okay, so E0 equals to 120 Newton per Coulomb, and its frequency is F is equal to 50 Hertz. So these are the information is given. So E0 is given. Okay, now we know that E0 by B0 is speed of light c. So B0 is E0 by c, that is 120 divided by 3 into 10 to the power of 8. So it will be 40 into 10 to the power of -8 or 400 nano Tesla. So obviously magnetic field is correctly computed. What about angular frequency of electromagnetic wave? Angular frequency or omega is given by 2 pi f. Okay, Angular frequency or omega is given by 2 pi f. Now f is 50 megahertz. So 2 pi into 50 megahertz means 50 into 10 to the power of 6. Mega means 10 to the power of 6. So it will be 100 pi into 10 to the power of 6, that is pi into 10 to the power of 8 radian per second. Okay, so angular velocity is also correctly computed. Angular velocity is also correctly computed. Okay, what about propagation constant or wave vector? K equals to omega by c. K equals to omega by c. Okay, propagation vector or propagation constant is k, which is given by omega by c. So omega is given by pi into 10 to the power of 8 and c is 3 into 10 to the power of 8. So it will be 3.10 to the power of 10 to the power 8 cancels, 3.14 divided by 3, so it will be 1.4 radian per second. So obviously, as you can see, it is not 1.4 but it will be 2.1. So this is incorrectly computed. You can calculate the wavelength also. Wavelength is 2 pi by lambda. K is equal to 2 pi by lambda. From there you can calculate the wavelength, which will turn out to be 6 meter. Okay, so that will come out to be 6 meter. So K equals to 2 pi by lambda, and that is given by pi by 3. Sorry, 2 pi by lambda. So lambda equals to 2 pi into 3 divided by pi, so it will be 6 meter. Okay, so wavelength with lambda, wavelength with omega, wavelength with frequency, everything is related. So this is a very tricky question in 2021. Okay, so propagation constant is incorrectly corrected, remaining values are all correctly answered, right? I'll cover all these afterwards. Thank you, Sanjana. Don't worry, all the questions are discussed in detail and some other concepts also discussed. Some students had some doubt. So if you still have any doubts, don't forget to mention that in the comment section. I'll be back with new lives, and the lecture are also, all the Masterstroke lectures will be coming from next week onwards. So don't go anywhere. Don't forget to subscribe to our channel if you have not yet subscribed. I'll be back in with bang with new lives very soon. Till then, bye.